Okay, we need to take a little break and do a little bit of algebra in order to break and do a little bit of algebra in order to figure out how to solve some of our exponential growth model problems. We want to take a look at something called the common logarithm. Now, the common logarithm is written log of something. I'm just going to call it x. What that does is it undoes the exponential 10 raised to the x. Okay, like you think about adding 2 undoes subtracting 2. Taking the square root undoes squaring. So a log says undo the reverse of 10 raised to this. So in other words, the answer to a log of x is the exponent you need to put on 10 in order to get x. I know this sounds kind of crazy at first, but I promise a couple examples and it'll make a lot more sense. So if I take log of 10 raised to the x, I'm going to get back my x because the log is undoing raising 10 to the x. Similarly, if I take 10 and I raise it to log of x, I'm going to get back my x. They undo one another. All right, so it's not multiplication. We're not multiplying log times something. It's just a notation, just like a square root symbol is a notation. So here I have square root of 25. When I see square root, that little symbol thing, that's in my mind being interpreted as find a number times itself that will give you 25. So I interpret that way, and then I know the answer is 5. Likewise, when I see a log problem like log of 100, I'm going to, in my head, interpret that and say, okay, log of something means find the exponent on base 10 that will give me 100, right? What exponent on 10 will give me 100? In other words, in algebraic equation, 10 raised to what power equals 100? Well, I know 10 times 10 is 100, so 10 squared is 100. So the answer here is going to be 2. Okay, so my answer for this one, oops, wrong pen. My answer for this one is going to be 2. All right, let's look at another one. What about log of 10,000? Well, it's the same question. It's 10 raised to what power will equal 10,000? One nice little trick about tens is that 10 to whatever power, that power is telling you how many zeros you have, right? 10 to the first is 10, 1 0. 10 squared, we just saw, is 100 with 2 zeros. So how many zeros? 1, 2, 3, 4 zeros. So I know that 10 to the fourth equals 10,000. So the answer for this one would be 4. Okay, so a log, when you see log of something, it just means find the exponent on base 10 that will give me that answer. All right. One other thing I want to go through here with these is a property of logs. So if I take the log of something that's raised to a power, I can bring that exponent out and multiply it times my log. So here are a couple examples. I have the log of 2.5 raised to the third power. I can rewrite that and put 3 times log of 2.5. If I have log of 1.011 raised to the n, that exponent n gets out front, and n times log of 1.011 is how I could write that instead. This is what's going to be very, very helpful to us in solving our logarithmic equations, right? There's going to be a very simple 4-step process. Number 1, we want to isolate the exponential. This is critical. So whatever it is that's being raised to a power, I want that little chunk all by itself. I don't want anything added or subtracted to it. I don't want anything multiplied by it. I want just that little thing raised to the power all by itself on one side. Okay? Usually that's going to mean I'm going to divide. Then I'm going to take the log of both sides. Then I'm going to use this exponent property we just looked at, bring that exponent out front and multiply it. And then we're going to usually divide to get the variable by itself. Okay, I know that's very abstract, so let's take a look at an example. In a previous problem, we looked at the situation in Portland and population growth, and we were trying to determine when the population would reach 700,000. And we said that we were really needing to solve the equation 700 is equal to 1.011 raised to the nth power times 568. So what I'm going to do is apply that process we just talked about. So the first thing is to isolate, right? We want to isolate the exponential. Well, the exponential is the thing raised to the power, that 1.011 to the n. So we need to get rid of that times 568. How do you do that? You divide. So I divided both sides by 568. Now, I don't have to actually get an answer for 700 divided by 568. I don't want to round at this point. Just leave it as a messy fraction. That's perfectly okay, all right? So you don't have to get a decimal and round, because if you do, that's probably going to introduce some error into your answer. So just leave it, all right? Then do the next step, which was take the log of both sides. That's easy. You just put log in front of both sides. Then the next step was to apply that property, the power rule. Okay, so that exponent rule means I'm going to bring that exponent out front. So on that right-hand side, where I have log of 1.011 raised to the n, I'm going to bring that n exponent and put it out front and make it n times the log of 1.011. Don't change the left at all. All right, so we're solving for n. So now I need to get rid of this. It's n times something. So how do I undo multiplication? I'm going to divide. So I solve by dividing both sides by the log of 1.011. Okay, here's where you need to use your calculator. Now, I have a graphing calculator. You might have a scientific calculator. I have one of those as well. There are different types of calculators that we can use. I'm going to demonstrate using a computer scientific calculator. If this doesn't work on yours, let me know. We can talk about how your calculator works. So for my computer calculator, scientific version, because I want to have that log on it, what I'm trying to do is this left-hand side. A lot of times the scientific calculators require that I do the inside part first. Some of the more sophisticated ones do have a log button, and then you can put in what's inside the log. So again, your calculator may be a little bit different. But for mine, I'm going to take 700 divided by 568 and get my answer. And then I'm going to say, okay, calculator, take the log of that. And it gives me this ugly decimal. Then I wanted to divide, but I wanted to divide by the log of something. So I'm just going to be safe and put parentheses. And I put my inside in first, 1.011, and then I say log of that, and then I close my parenthesis, and then I hit equals. So I get about 19.1 for my answer. Again, your scientific calculator may be a little bit different. If you need help with that, just let me know, or the folks in the Academic Success Center would be happy to help you with that.